Hello students, myself Gurchan Singh Makheja and on the behalf of Narayana Academy, we are discussing JEE Mains 2024 Jan 27 Shift 2 papers. Hope all of you are doing great. So let's discuss this paper. The question number 1, the quantity which changes with the temperature. Before starting this, I'll just tell you these are all memory based questions. These are the questions which was told by the students who has attempted the paper. So there might be some changes in the actual paper, right? So this paper will give you a rough idea that how question has been asked in the examination. And all the best. Now, question number 1, the quantity which changes with the temperature, right? Now we know that the on changing the temperature, volume and density changes. So the quantity which depends on the volume will get affected by changing the temperature, right? Here we have mole fraction, mass percentage, molarity. Clearly molarity, which is equal to number of moles of solute divided by volume of solution in liters. Now here this term depends on volume. Clearly the answer will be 3. It changes with temperature. It's a very primitive question, NCRT based question within the syllabus. Very simple to ask. Everyone would have done it nicely, right? Now question number 2, which of the following cannot act as an oxidizing agent? That is MnO4 minus, SO42 minus, N3 minus, BrO3 minus. Now we know that an oxidizing agent should undergo reduction, and the atom which has the lowest which exists in the lowest oxidation state cannot undergo further reduction. So the answer for this thing should be N minus 3, because N minus 3 cannot further accept electrons. So the reduction of N minus, N3 minus cannot take place. So clearly the answer should be 3. Again the straightforward question, NCRT based, very simple question, right? Now question number 3, this question based on reaction of HI with ethers, and we know that whenever ether is connected to two alkyl groups whereby one is secondary, other is tertiary, the major reaction given by it should be SN1, right? So this molecule will undergo SN1 reaction, and we know that I have a secondary alkyl group and we do have a tertiary alkyl group, and when H plus activate oxygens into a good living group, it becomes, as this is SN1 mechanism, this bond will get broken down, and yes, it results in the formation of most stable carbocation, that is tertiary butyl carbocation, which will be attacked by a nucleophile, and here in this reaction we have I minus as a nucleophile attacks on tertiary butyl carbon, and it will give us. So the correct option should be 1. Hope every one of you understood this question nicely. We'll move to another question. The next question. Identify the following species in which D2sp3 hybridization is shown by the central atom. Now BRF5. Actually, for a student, it is very simple to understand that the coordination compound exists as D2sp3, while other molecules, the normal molecule, will use outer d orbital for the hybridization, right? Anyways, BRF3, F5, I have one lone pair, 5 bonds. The hybridization should be sp3d2. Then you have SF6, all the electrons are forming sigma bond. Again, hybridization is sp3d2. For cobalt 3 plus. Now, when cobalt 3 plus forms a ligand, a complex with strong field ligand, the hybridization comes out to be D2sp3. That is inner orbital complex. Now understand that cobalt electronic configuration is 4s2 3d7. For cobalt 3 plus, it should become 3d6 4s0. And when a strong field ligand like ammonia is donating the electrons to the cobalt, it results in pairing of electrons. So here the d orbital, the d6 electron will get paired up, and yeah, all the six ligands will form a coordinate bond with the inner d orbital and then outer s and p orbital. So clearly the hybridization becomes d2sp3. So the correct option should be 3. And we know that platinum 2 plus, either with strong field ligand or weak field ligand, always form square planar complexes, right? So the hybridization will be dsp2. So the answer for question number 4 is 3. Hope all of you have done it correctly. Now, question number 5. The phenolic group can be identified by a positive Lucas test, carbylamine test, Thalline test, and tolerance test. See, the thing is, Lucas test will be given by those molecules which can form stable carbocation, and we clearly know that positive charge on benzene molecule is highly unstable. Carbylamine test is for amines, and Thalline test, yes, when you react phthalic anhydride with phenol in the presence of concentrated H2SO4, you know that a condensation reaction takes place whereby the overall molecule which we will get over there will be it form phenolphthalein. So yeah, Thalline test phenol gives. So answer should be 3. Again, this is NCRT based question. Everyone would have read it. So everyone would have done it correctly. So we'll move ahead. Which of the following, which of the protein intact after coagulation of egg white on boiling? Now we know that a primary structure is nothing but from N terminus to C terminus, the arrangement of amino acids. Amino acid 1, amino acid 2, likewise many amino acids are forming a linear combination with few disulfide linkages, right? And then the coiling takes place to form alpha helical structures and then beta pleated structure. These are primary secondary structures. When these secondary structures attract each other, it forms a tertiary structure. Now, in a full-fledged protein molecule, you will have multiple structures like primary, secondary, and with the help of hydrogen bonding, they will attract each other. Now, when you heat primary, secondary, and tertiary structure, when you heat primary, secondary, tertiary, and quaternary structure, nothing will happen to primary structure, and secondary, tertiary, and quaternary structure will undergo uncoiling, and yes, it will convert into primary structure. So the correct option for this answer is primary structure, because tertiary, secondary, and quaternary structure will uncoil into the primary structure. Nothing will happen to primary structure per se. So the correct option is primary structure. So this is a very basic theory question from biomolecules, and the effect of external atmospheric condition, pH changes on protein, how it changes its structure. It came from this topic. Hopefully you have read that nicely and you would have done it correctly, right? Now question number 7. The molecular formula of second homologue in the homologous series of monocarboxylic acid is very simple. The first carboxylic acid is formic acid, first homologue. The second, add alkyl CH2 group over there. So this is acetic acid or ethanoic acid. That's the second homologue. Straightforward question, simple question. So correct option should be answer number 1. We'll go to next question. Which of the following will not give SN1? Now the molecules which undergo SN1 reaction should form a stable carbocation. Just remove leaving group and form a carbocation over this. If the carbocation is stable, it will undergo SN1 reaction. Right? Now the first option, you have allyl chloride. Remove Cl minus, put a positive charge. This positive charge is stabilized by resonance. Yeah, it is stable. It can form easily. Second, you have benzyl carbocation. Again, this is highly stable, stabilized by resonance again. Then you have a positive charge on vinyl type carbon. The positive charge on sp hybridized carbon will have 50% of its character. Now, because of the 50% of S character, it will become highly electronegative, and positive charge on electronegative atom is highly unstable. Moreover, in vinyl type system, if you have vinyl type system, there exists resonance between pi bond and chlorine, and because of that, you will get a partial pi bond character, and it is very difficult to break that pi bond, right? So yeah, these molecule will not undergo SN1 and SN2 also, right? For tertiary butyl, remove Cl minus, put a positive charge over there. You know that this positive charge will be stabilized by 9 hyperconjugation structure. And because of that, it is highly stable. So clearly the answer is vinyl type system. So answer is 3. Simple question, right? So we'll move ahead to question number 9, in which all have D10 configuration in the ground state. If you just go through the option, you'll get the clear idea. Even with 10 seconds, you'll come to know the answer is the question, the option number 1. Now, why option number 1? Copper. What is the electronic configuration of copper? That is 4s1 3d10. Zinc. That is 4s2 3d10. Cadmium. 5s2 4d10. Silver. 5s1 4d10. Now they all of them have this completely filled D electronic configuration. So answer should be 1. Very simple question. Very simple question, right? Okay, you understood that part, right? Okay, compare the stability of resonating structures. Now, in order to compare the stability of resonating structures, first this canonical structure which will be neutral and have more number of pi bonds, the more number of bonds is more stable, right? Here you have this molecule. In this molecule, it is completely neutral, have more number of bonds, right? And then you have this particular structure which have some charges over it. A number of bonds are more only. And in this molecule, the number of bonds are very less. Lesser the number of bond will indicate that the octet of any one of the atom is not complete. So here the octet is not complete, it's an incomplete octet. Here complete octet. Here complete octet. Here also both the oxygen atom and every atom has complete octet. So the molecule which is neutral will be highly stable. Then this molecule which will be stable, and the molecule which has incomplete octet will be highly unstable. The stability aspect will be first is more stable than 2 is more stable than 3. So clearly the option should be 1. Hope you would have understood this. Again, this question is a very simple question based on GOC, right? General Organic Chemistry, within the syllabus only, right? Now this question is good. Here you have multiple things which are involved in this question. Here benzene, C double bond C known as styrene. Now first you are reacting this styrene molecule with B2H6, this is hydroboration reaction, hydroboration oxidation reaction, and we know that this is anti-Markovnikov addition of water, right? So yes, it results in the formation of 2-phenyl ethanol, right? This will be 2-phenyl ethanol, right? Now second, you are reacting this molecule with HBr. Now here H plus will activate OH into a good living group, and I have alpha, beta. I have a beta phenyl group that will involved in NGP. Moreover, there will be large amount of Br minus which will undergo SN2 reaction. Right. So major product which I'll be getting over here will be and after that you'll have magnesium ether, where we will be getting C minus Mg plus Br, this Grignard reagent, and on addition of Grignard reagent on formaldehyde molecule, a nucleophilic addition reaction takes place whereby this attack on C delta positive charge, pi bond will shift, and subsequent hydrolysis will result in the formation of so the correct option should be 4. Now here in this question the major contributing factor is NGP, right? Moreover, subsequent amount of SN2 reaction takes place, so the major product should be this one, right? And from there we'll move ahead. So this question is a good question, right? Few student will make silly mistakes in that, but anyway it is within the syllabus, and yes, a very nice question. We'll move ahead with question number 12. The technique used for the purification of steam volatile water immiscible substance is. Now this is a direct question, memory based question. Now, whenever any particular molecule which is steam volatile and is immiscible with water, the separation technique which we will employ is steam distillation, where on passing of steam inside a solution which is immiscible with water, the vapor pressure of steam plus vapor pressure of compound will collectively results in the boiling of the particular organic compound which you want to separate, right? So it's a very simple question, direct from NCRT. If you have read that thing, any student can do it nicely. Next, question number 13. The value of delta H naught, delta S naught for a process. See here, generally a student makes the mistakes in units because the question is very simple. Into 10 to the power 3 joules and delta S naught and delta S naught is given as 48 joules per Kelvin, right? Now find the value of log 1 by k. Here k is equilibrium constant, right? Now here first you calculate delta G naught. Now delta G naught is defined as delta H naught minus T delta S naught minus T delta G naught is defined as delta H naught minus T delta S naught, right? Here delta G naught will be delta H naught is 77.2 into 10 to the power 3 minus your 300 into 48, right? So after getting this delta G naught, right, which is 62.8 into 10 to the power 3 joules, right? And after that, just put delta G naught is equal to minus 2.303 RT log K. So delta G naught comes out to be 62.8 into 10 to the power 3 is equal to 2.303. R is 8.31. Temperature is 300 Kelvin. Minus log K is log 1 by K. So log of 1 by K is equal to 62.8 into 10 to the power 3 divided by 2.303 into 8.31 into 300. That overall comes out to be nearly 10.9. So nearest integer comes out to be as 11. So the correct answer should be 1. Hope you understood the technique. And yes, again this is NCRT based. Again this is NCRT based. If you are very good in NCRT, you can easily solve this question, right? So next question, right? Which of the following statement is correct? This is again a memory based question. And yes, Ce plus 4 have high tendency to gain electron to become Ce plus 3, right? The amount of energy liberated when Ce plus 4 positive 4 charge gains an electron will be very high. So the electron gain enthalpy of Ce plus 4 is very negative. That is why large amount of energy liberated, which makes the E naught value of Ce plus 4 to Ce plus 3 quite high in the range of 1.74. Hence, it acts as a strong oxidizing agent. That is correct. So, answer is 1. Isn't purely a memory based question, right? Next, question number 15. oxygen is always present in -2 oxidation state. This is statement 1. We know that oxygen has multiple oxidation state. It can exist as -1, -2, it can exist as 0. Moreover, in superoxide, it can exist as -half also, right? Yeah, in O2F2 +1 also, in OF2 it is +2 also. 0 in O2, H2O -2, and H2O2, that's peroxide, is -1. So clearly, oxidation does not have only -2 oxidation state. Statement 1 is false. Now for statement 2, stability of oxidation state of group 16 for +4 and +6 decreases down the group. There is a very predominant effect known as inert pair effect, and because of that, yes, stability of higher oxidation state decreases down the group. So statement 2 is correct. It's true, and it's because of inert pair effect. Because of that, the correct answer should be statement 2 is correct, statement 1 is false. The answer should be 4. So the next question is question number 16, right? Here is a very simple question of normal substitution reaction. Here you have alkyl halides with excess of ammonia. So ammonia is in excess. It will undergo an SN2 reaction here as well as in here. So on both the primary carbon and terminal position, both the halogen will be substituted by ammonia molecules. After the substitution of ammonia by ammonia molecules, it gives N positive, H, 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 N positive, H, H, H. I'll get an aminium ion. When I'm adding base NaOH, this OH minus will extract H plus from these aminium ion, right? From this aminium ion. Thereby, you will get C, 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 NH2, NH2 as a major molecule. The answer should be this, right? So we'll move ahead. I guess every one of you have found it very simple. So we'll move ahead, right? Now we'll start with the numericals. Till now, the objective questions which we got from the students, right? We have discussed those questions. Now, question number 21, right? Yeah, there's a first integer question. Now, for a first order reaction, T 99.9 is equal to x times T half. Now, listen, for first order reaction, you know that ln A naught by AT is actually equal to KT. And when T is equal to T half, AT is actually equal to half times A naught. And when T is equal to T 99.9, that means 99.9% of the reactant is reacted. That means the amount which is left over, AT, is equal to 0.1% of A naught. That comes out to be A naught by 1000. Getting it? So thereby ln A naught by A naught by 1000 should be equal to K into T 99.9. Right? Here from this you will get ln A naught by A naught by 2 is equal to K into T half. Right? Now, in this question, they're asking you the ratio between T 99.9 divided by T 50%. That comes out to be how much? So, this is T 50%. If you divide both the things together, so you will get ln 1000 by ln 2. That clearly is 3 by 0.3. 2.303 will get cancelled, so answer will be 10. So the numerical value for x is 10. Simple question. Everyone of you know that a good student should know what is T 99.9, right? We'll move ahead to the next question. That is question number 22. It is a very simple question of concentration terms and mole concept. Now, if 84 grams of NaOH is present in a 3 molar solution, find the volume of a solution. Now, if you know molarity is equal to number of moles divided by volume of solution in liters. So, molarity is given to me as 3. Number of moles we can easily calculate. That is weight by molecular weight. Weight given is 84. Molecular weight of NaOH is 40. And volume in liter we have to calculate, right? And we have to report the answer in ml. So, V in liter comes out to be 84 by 40 into 3. That comes out to be 0.7. That is the answer will be 700 ml. Very simple question, right? So the numerical value is 700 ml. Hope you have done it nicely. Everyone will get the answer easily, right? Now for the next question. The number of non-polar molecules given following. Okay. Now non-polar molecules means the net dipole moment should be 0. I have H2O molecule where you have two lone pairs, two bond pairs. The resultant dipole moment will be towards the lone pairs over here. And yeah, H2O has net dipole moment, so net dipole moment will not be equal to 0. SO2 again contains a lone pair and bond pairs. Again, this will be towards oxygen, and here towards lone pair. The net dipole moment will be towards oxygen, and hence net dipole moment will not be equal to 0. BF3, trigonal planar geometry, sp2 hybridized molecule, which also show back bonding. Here, here, and here, the net dipole moment will get cancelled. It should be 0. For hydrogen, the electronegativity difference between the hydrogen atom will be 0. Then hence the net dipole moment will be 0. In CHCl3, we know that chlorine is more electronegative than carbon. The direction of dipole will be towards chlorine. And carbon is more electronegative than hydrogen. Direction of dipole moment will be towards carbon. The net dipole moment will be down. Hence, the dipole moment will not be equal to 0. So, the non-polar molecules in the given molecules, like what are the non-polar molecules where the net dipole moment is not equal to 0? So, the answer should be 3. Simple question, chemical bonding problem, very simple. Every student can do it nicely, right? Next, question number 24. If the longest wavelength for Passion series, see, whenever they are asking about longest wavelength, right? We know that E is equal to H nu, right? And greater the energy, greater will be frequency, and lesser will be wavelength, right? So I want to calculate the longest wavelength over there. That means the energy should be minimum for Passion. Okay. So you have Lyman, Balmer, Passion, Bracket, Fund, Humphrey, so on. Right. Now this is N1, N2, N3 for Passion series. Any electron which is falling from any level to third level comes under Passion series infrared region. Here The highest energy will be given by infinity to 3 and the lowest energy will be given by 4 to 3. So lowest energy is this. So maximum wavelength will be here for passion, right? So we'll apply the Rydberg formula, that is 1 by lambda wave number is equal to Rydberg constant R into Z square for hydrogen, Z is 1, into 1 by N1 square minus 1 by N2 square, where N1 should be lesser than N2, right? So 1 by lambda is equal to R into 1 by N1 square, that is 1 by 9 minus 1 by 16, right? So here I'll get lambda is equal to 9 into 16 divided by 7R. That means what the value of alpha, that is 9 into 16, comes out to be 144. Hope you understood this problem. It's very simple. Rydberg constant, Rydberg formula. You just apply it from atomic structure. Just apply it and get the answer. Very simple, right? So we'll move to next question. Question number 25. How many of the compounds given below have chiral carbon? Now, what is the chiral carbon? The carbon which contains all four different substituents, and it should be sp3 hybridized, right? Here you have CH3 and C double bond O. This carbon, check. I have hydrogen, CH3, some other group over here, and I have a C double bond O, some other group over here. Clearly, this carbon is chiral. This contains a chiral center. Here, whatever sp3 hybridized carbon I have contains two same hydrogen atoms. So none of the atom is, or none of the carbon is chiral over here. Next, you have this carbon, iodine, hydrogen, and two ethyl groups. This group is same as this group. Again, no chiral center, right? And next, you have carbon, carbon, carbon with a COH group. One hydrogen is there, one ethyl is there, and one more OH is there. So clearly, this carbon contains all four different substituents. This is chiral. So how many compounds given below have chiral carbon? Answer is 2. Hopefully you understood that. Very simple question again from isomerism, right? The stereochemistry. We'll move ahead now, right? Now question number 26, that is photoelectric effect. Uh, very simple example is all example of NCRT itself, right? It's more or like that only. A work function, what is work function? The energy required to just eject an electron from a photoelectric plate. So if you have a photoelectric plate, you do have an electron, the minimum energy of a photon which is required to just eject that electron out of the plate is known as work function. So this photon should have 6.6 electron volt of energy. So if I know the energy of the electron volt, the photon, so I can easily calculate the frequency of the photon. We know that energy E is equal to h nu. So energy is equal to 6.6 into 1.6 into 10 to the minus 19 joules is equal to h 6.63 into 10 to the power minus 34 into frequency. Now in the question it is mentioned that take h as 6.6. So fine, we'll take h as 6.6. So I'll get 6.6 into 1.6 into 10 minus 19. The calculations are very simple also there. 6.6 into 10 minus 34. It'll get cancelled. So the answer of this question comes out to be your 16 into 10 raised to power 14. So x value is actually equal to 16. Any student who has chosen this question is like free marks. Very simple. Okay, question number 27. Yeah, now you have a hydrogen electrode, electrochemistry based question. Okay. Now the direct application of Nernst equation in this particular question, right? Now they have given you, they are preparing a hydrogen electrode at pH 3. So the H plus concentration in which you are dipping hydrogen electrode is 10 is to power minus 3 molar. Now they want you to find out the electrode potential, right? Very simple. Here, write down the reduction reaction. 2H plus aqueous plus 2 electron gives hydrogen gas. When the partial pressure of hydrogen gas is not mentioned, generally take 1 bar. And the concentration of H plus, take it as 10 minus 3 molar, right? Now here, apply Nernst equation. That is E is equal to E naught minus 2.303 RT by NF log of product by reactant. This is partial pressure of hydrogen divided by concentration of H plus whole square. Right? Here I want to calculate E, which is equal to E naught is 0 minus 0.0591 by n factor. See, this value, direct value is 0.0591 and n factor given to us as 2, where log of 1 by 10 is to power minus 3 whole square. So E value comes out to be here minus 0.0591 by 2 log of 10 is to power 6. It comes out to be 6 into 0.0591 by 2 is asking you the magnitude only. So when you calculate it, you will get it as 0.1773 volt. So in the format he has given, so 17.73 into 10 to the power minus 2 volt. So what is T? The nearest integer value comes out to be 18. So numerical answer for this should be 18. Hope you understood this particular question. Direct application based nurse equation you have to put and you'll get the answer. Right? Now magnetic moment of a complex in question number 28. The complex is given to you palladium. The oxidation state of palladium is +2, and we know that palladium forms square planar complexes even with weak field ligand, and the pairing of electron takes place. So palladium 2 plus, the electronic configuration is 4d8, and if the pairing of electron takes place, so we'll have d8. In d8, these are the orbitals where the pairing of d electron takes place, and here so students, we'll start another question number 28. In question number 28, they have given us a complex, that is palladium. The oxidation state of palladium is +2. So we know that palladium always forms square planar complexes even with weak field ligands, and the pairing of electron takes place. The palladium 2 plus electronic configuration is D8. If you check the orbital diagram, all the D8 electrons are filled, and yes, one s orbital, outermost p orbital. So this is your 4d, 5s, 5p. So the hybridization you will get as dsp2. right? Square planar complexes. This is square planar. All the electrons are paired up, so magnetic moment is actually equal to 0, right? So answer should be 0. Very simple question. Just look the molecule and you can do it. Now we'll move to question number 29. How many of the following given atomic number have noble gas electronic configuration? Very simple method. Now helium 2, add 8, then you'll get 10. Add more 8, you will get 18. Then add again 8, you will get 36. Then again add 18, you will get 54. Now add 32, you will get 86. Then again add 32, you will get 118. This is a shortcut to calculate all the atomic numbers of noble gas elements, right? Now, here just match the atomic number which is given to you: 56, 57, 70, 80, 24. None of the match, none of the elements atomic number is matching with the noble gas electronic configuration. So, answer should be 0. Now, this question will take not more than 30 seconds to solve this, right? Very simple question, right? NCRT based primitive questions. So we'll move ahead now. We'll go to the final question. That is question number 30. Here you have 9.3 grams of aniline is reacted with acetic anhydride. Mass of acetanilide obtained is m gram. Find out the value of 2m. Now you know that whenever you have aniline, in the protection of aniline, we generally react with acetic anhydride. When aniline react with acetic anhydride, a nucleophilic addition elimination reaction takes place, which results in the formation of acetanilide. Now, even if you don't know the actual reaction, they have already given you the general name for the particular molecules, right? Now, aniline is 9.3 grams. The molecular mass of aniline is 93. So 9.3 divided by 93, I have 0.1 moles. 1.1 mole will react to give 0.1 mole of compound, and 0.1 mole into its molecular mass. The molecular mass of this molecule comes out to be your 135, and the overall mass comes out to be 13.5. This is the value of m. So you want 2m, so 2 into 13.5. Answer given is 27. So answer for this question should be 27. So this is the end of discussion for the paper, right? And the students who are watching this video can come to know that these all are very simple questions. The entire paper was NCRT based. Again, these are memory based questions, but it will give you a clear cut idea that how and what is the level of question which JEE Mains is asking in Jan shift. Hope you have enjoyed that video. All the best and good luck for your examination. Take care.